You want to keep your data private. You've got Gamma and Quen invited. You want to know how to serve them right? I'm going to show you Dentro style. When using a large language model, typically you have two options. Either you use a hosted version or you use a self-hosted version. With the hosted large language model, you use a service provider such as OpenAI, OpenRouter, Mistral, etc. What you do, you sign up there, you get an API key to authenticate yourself, and you send a request to their API, and you get back the response from the large language model. For each request that you send, you pay depending how much tokens you send, and the data is processed by the service provider. Now, with the self-hosted, you set up your own infrastructure and you run there a large language model. The advantage of using hosted versions is that there are no upfront costs. It's in general much easier to set up. And you can use closed source models such as Claude from Anthropic, the latest OpenAI models, and others. With the self-hosted approach though, the main advantage is that your data stays private and you can be sure because it never leaves your on-premise infrastructure or your local machine, your laptop. There are other advantages. Of course, if you process a lot of LLM requests, then it's probably cheaper to run your own hardware because you only have to buy it once and then you pay every month for the electricity cost or wherever you run it. We use hosted LLMs all the time. However, we're also aware that many individuals and especially corporations, businesses, don't want to give up their data to the third party. And this is what we're going to look at today. How to choose the right infrastructure to run your large language model, either on your laptop or on the cloud service or on your on-premise data center. Data center is maybe too much, on your on-premise servers. And we will rent an instance in the cloud, a GPU instance. We will use Ollama and vLLM to run some LLMs. So, how do you choose the right large language model for you? Well, there are three things, depending where you're from, that you should think about. First of all is the hardware. How strong is the graphic card that you have? Second one is which LLM do you want to run? Which capabilities should it have? And the third one is which LLM runtime you want to use for inference. The last one is rather easy. There are two major services, tools to run your LLM. One is Ollama, the other one is vLLM. There are also more, of course. There is Llama-File, there is, Yan, some stuff, but these are the major two. Some models run on both of them, some only on Ollama, some only on vLLM. We get to that in a bit. Now, let's check out the large language models. How do you know which one is the right large language model? Should you use DeepSeek because your boss told you, hey, my NVIDIA stock went down because of this model, it must be great? A great place is, for example, the chatbot arena. It happens that users put the preference to certain answers. So, for example, if you write here, if you run this again, I did this already before, a new round, tell me a joke. And then two large language models run in the background, and they both tell me a joke. So here, what do you call a fake noodle? An imposter. No, not bad. Why did this scarecrow win an award? Because it was outstanding in his field. Well, also not bad, but I like this one more. So I say A is better. And now I see which one they were. So this one was the Mistral 24B, and this one was Moon Howler. Wow. And now based on my voting, the Mistral 24B got some points. And that way I can directly influence the leaderboard. And this is very good because typically when a new model is released, the makers of the large language model put certain benchmarks where the model performs very well, and maybe others they don't showcase because it doesn't perform so well. So the chatbot arena is the gold standard to figure out which model is the best currently. And we can see currently the best model is the recently released Gemini 2.5 Pro. Then we have the 4.0 from ChatGPT from OpenAI. What's interesting for us are the models that are not proprietary, that are not closed source, because these are the ones that we can sell first. And we have here on rank 5, DeepSeek R1. And this is MIT licensed, so anybody can run it. Then we have here, next one is the Gemma model, next best open source model. This is a bit of a different license. You can also run it yourself, but would be better, of course, if you read it first, because the ones that are very safe are always MIT and Apache 2.0. So here we have like the Gemma, then we have a DeepSeek license for DeepSeek V3, DeepSeek V3, DeepSeek R1. One is a reasoning model, one is a non-reasoning model and more a coding model. Here we have the recent reasoning model from Qwen, the 32B, and so on. Now let's say you like a model based on its ranking, then you should figure out what capabilities does it have. And this you typically do by Googling. So you just type in, DeepSeek R1. Then you figure out, for example, does it support image input? Does it have so-called vision? DeepSeek R1 does not have vision. You cannot give it an image and ask what's on the image. But maybe you need it for your use case because, for example, many businesses have documents that they want to understand with the LLM. And for this, a vision LLM is very useful. Another thing is function calling. Is the LLM fine-tuned so that it's very good at calling programmatic functions? And this is very useful when you want to build something more difficult, more complicated than just a chatbot. Most of the new ones have function calling in general. Vision don't have a lot. There are also other things like how good is it in certain languages, but this is something that changes all the time, and you should look up in the internet at a certain point when you want to run your model. Now, the next very important thing is that you know how many billion parameters the model has that you want to run, because the billion parameter influences quite a lot which hardware do you use. The more billion parameters, the more hardware you need in general as a rule of thumb. Here you can't see how much billion parameters they need. In other lists you may be. Now we will go to Ollama. If you're here on Ollama, you can go to models. And here you see all the models that are optimized for Ollama. The thing is, we will use now Ollama and also vLLM. Here are the GitHub pages also of both of them. And both of them need different model formats. So Ollama is more for personal use and vLLM more for production use case. But you can use both for your personal use and both for production. Just the thing is that the Ollama models, the so-called GGUF models, this format, is optimized to be loaded in quickly into the memory and unloaded quickly. With vLLM, on the other hand, these models are optimized not to be loaded in quickly, but to be very good at runtime, at inference time. So Ollama is better for personal use because it's easier to tinker around. You try one model, then you try another model. With vLLM, this is a bit of a different thing. And the very cool thing about Ollama is that in the model list, you can see already how much billion parameter a model has. So for example, if we go now to the DeepSeek R1, we can see here with the tags, it has a 1.5 billion version, a 7 billion version, of 8 billion, 14 billion, 32, 70, and 671 billion version.
That's awesome.
Now, the more billion parameters, the better it is in general. And this one is the one that, made the whole world aware of DeepSeek, the 671B model. For this, you will need a very strong hardware. So typically, like rule of thumb, is if you don't have any GPU, then you can use like very small models like this 1.5 billion. If you have a GPU like me, I have 8 GB vRAM on my NVIDIA card, then you can run like 7, 8, maybe even 14 if it's then slower, this kind of models. And then later on you need more vRAM, like 32 to run fast, or like 30 GB vRAM for 70, 80, like for this one 40, for this one 80 GB vRAM, and for this one probably like 250, 300, something like that. I never ran the biggest one, but we will run today the 70B model. And it's the same with others, like here Gemma, the one from Google recently released. It's in general a smaller model. The biggest one is 27 billion, but you can see that it still performs very well, even though it's so small. So here you obviously always see the biggest model sizes that are here in the arena. Here you also see the 27B, right? And here the DeepSeek R1, it must be the 600B model. So the thing is that, look here, you get like almost the same quality as DeepSeek R1 if you use a much smaller model from Gemma, which is pretty amazing. But hey, who knows what DeepSeek will do in the future? And how do you find models with vLLM? They don't have such a cool site. But with vLLM in general, you can run any model. So if we run here, we just look for DeepSeek, yeah, DeepSeek R1. Here we go. Then you can just run this. And the nice thing is here you always have the button how to run with vLLM, and we already have the how to do it, like without Docker and with Docker. The only thing is with vLLM, it's a bit trickier. Why? Because all these GDUF models on Ollama, they are already made smaller. They are quantized. That means that typically every model weight of a model has 16 or 32 bits. Now what you can do is you cut it in half, for example, to 8 bits. And what happens is that the model only needs half of the space in storage and in memory, approximately half. And this is like amazing because suddenly you can run these big models on smaller hardware. And if you then cut it in half again by using a quantization of 4-bit precision, then it's even easier to run on small, weaker hardware. And here, when you're here in this list, all of them are already 4-bit quantized, which is nice. However, if you look here up, this is not 4-bit quantized. This is like, here, this is I think the original, no, 16 bits, something like that. But if you look for so-called AWQ models, yeah, let's look for 70B AWQ. Here, for example, this one. This one has a 4-bit precision. So this one is, you can run it on, you need less hardware to run it than the 8, 16 or 32-bit. This was actually wrong. This is the tensor type. I think before we had like here, this was, this is maybe already 8-bit precision. I'm not sure. If you have an AWQ model, this is optimized to run for vLLM and other things in an optimized way. This is the thing, right? So the quantization of the models to keep in mind, because it can happen that your colleague runs a 70B DeepSeek on a 80 GB vRAM machine, and you can't do it, and it's just because he uses the 4-bit quantization and you use the 16-bit quantization. And then another thing what you have to keep in mind is the context window size. So the context window size is how many tokens you can feed into the LLM and get back. So the total is the context window size. The bigger the context window, the more memory you need. And this can become quite big. We will get into this also in a bit. Now we know what we have to think about. What are the capabilities? Yeah. For example, let's say I don't want any vision. Yeah. Gemma would have vision, but I don't want it. I want the DeepSeek R1, run the 70B model. I need a graphic card with around 80 GB VRAM. And now where do I get the graphic card from? Hopefully you have it at home. Probably you don't. So that's why we can rent an instance in the cloud. And what I like to use, especially for testing out, because it's very easy to use and good price, is Paperspace, some company that got acquired by DigitalOcean some years back. You make an account, put your credit card there, then you click on create a machine, and you have some options. Now, something that I don't like too much about this view is that it doesn't show you the GPU RAM. So for example, here the H100, it has this amount of RAM, but it doesn't tell you that it has 85 gigabyte of vRAM. Yeah, if you go to others here, it also doesn't tell you. So this is not so cool. So you have to actually do some research again yourself. How much RAM it has. But well, this is all part of the journey, right? We will use the H100. It's the newest from NVIDIA. Actually, it's not the H200 are the newest, but this is a very strong card. We will use the ML in a box image, which already has a lot of stuff pre-installed, like NVIDIA drivers, Docker, and so on. Let's use the 250 gigabyte in case we want to install a couple of models, and we call this Showcase. Now we will select some network. Yeah, the Showcase network. Let's go with this one. And that's it. It will cost $6 per hour. So for testing, it's good. If you run it for a whole month, well, you can calculate that it will become a bit more expensive, and maybe it's cheaper to just buy yourself H100 instead of renting it in the cloud. This will take a little bit. Let's wait until it's finished provisioning. Great, now it's ready. And if we click here on connect, we already have the command to connect directly to the instance. And the cool thing is if you put your SSH key on the platform, that you're logged in immediately, and now you're here. Now we can check out how much vRAM we have. And this is 81 maybe bits, I think, yeah. Let's check it out, how much it is. I already put it before, yeah. 85 gigabyte of vRAM, which is great. And now we want to run some stuff. With the ML in the box image, we already have Docker already installed. And now using Docker, we will run Ollama and vLLM. You can, of course, run them without Docker both. It's just in case you want to do some production use case, then, well, cross-platform, it's much easier to use Docker. You can check it out here on the website, or just in the footer, in the description below, you will find the command. Here, the command to run with an NVIDIA GPU. Something I didn't touch on before is it's in general much easier to run on NVIDIA graphic card something than on AMD, just because the CUDA universe is much bigger than, I don't know how it's even called for AMD. I just know that it's some open framework. But yeah, this let's run this. And it will run the Ollama server. And what we have to do after it's downloaded and installed is to actually run a large language model. So now we just run like the software to run the large language model, which is called Ollama. Okay, now it's installed, and we can see here the Ollama container. We can go inside the container and see right now we don't have any models installed. And if we go over to here, for example, the 70B model of DeepSeek, we just run it like this. And this can be done from within the container. You can run text Docker exec from outside the container. What's important here is that it takes 42 gigabyte of storage. So this is something to keep in mind. And typically, the models need around half the storage space that they have billion parameters. So if you have a 70B model, it takes around half, like 40 gigabyte storage. If you have a 30 billion parameter model, then it takes around 15 gigabyte of storage space. Okay, great. Now we're almost ready. There we go. Hi, how are you? Great, and I get an answer. Awesome. Now let's go out of here. We have now in our Ollama list the model that we just downloaded. And if I put Ollama PS, I can see how much gigabyte of VRAM it needs. So currently it needs 46 gigabyte of VRAM. If we exit the Docker container and check on the system, the NVIDIA card, then yeah, it fits. It's like 56 gigabyte of VRAM. Now, if you want to properly test it, you want to benchmark it, run some example prompts against it, then of course you want to make API requests, and you can do this like this. We ran it before on this port, and then you just have to put the right model name here, which is not the correct one right now. We have here this one. And the prompt is who was Albert Einstein, and we can make stream true. And now you can see, boom, immediately it starts, and every response is here a part of something. Like, for example, was a renowned German-born theoretical physicist who revolutionized our understanding of the universe. Each of these words is a token, and it ran very fast. I don't know what was the token speed per second, but was very fast. We have this, and what you have to keep in mind, or what you have to know, something that I didn't know in the beginning, is that the default context window of Ollama models, all the Ollama models, is 2048 tokens. And this is not a lot if you have anything else than just some chat. If you use some retrieval augmented generation pipeline, then it's definitely not enough. And what I suggest is having at least a context window of 64,000 tokens to be flexible in the future. Now what we can do is we can increase the context window size in Ollama. And there are two ways to do this. I will only show you one for now. And you do this just by adding at the end this num_ctx. And here what we can do is we can now increase the context window size. For example, let's put it to 32. Yeah, this model doesn't exist. This is true because we run the bigger one. Now you can see it doesn't stream immediately. It doesn't stream immediately because it has to change the model that is currently loaded in memory a little bit. Once it's loaded, it streams again very fast. When it's done, let's try it again and see if it starts again as quickly. So now it starts again as quickly. Perfect, because we use the same context window size. The thing is, when you change the context window size in the request, for example, now we use, I don't know, 34, then again, it takes a little bit because it has to change how it's loaded in the memory. And so if you have an application, make sure to always send the same context window. You can also create a custom model file and create the model from there. Then you don't have to send this num_ctx, but in my experience, it's very similar. What's now happening is that we want to see how much of RAM it takes, VRAM. More. Before it was like, I think 46. No, now it's 58. If we check also out the Ollama command, then yeah, you can see 50, almost 60 gigabyte of VRAM is now needed. Also, something that you can see here with Ollama, which is interesting to know, is that the models are by default loaded in for 5 minutes into the memory. After 5 minutes, it's unloaded. So if you make after 5 minutes a request again, it takes a little bit of time to load the model in. You can increase this default. The cool thing about Ollama is that because the loading in is made very easy, you can have multiple models downloaded, and then you make a request to DeepSeek, it loads in the DeepSeek model. Afterwards, you use a Mistral model, it loads in the Mistral model. And this is very easy to use. This is why it's very nice for personal use. Now let's increase the context window size by a lot. Let's put it now at 100. At 100. Let's see if it works with 100,000 tokens. We can see it works, but you can see the token per second speed is a bit slower because, well, it fills out more of the VRAM. Okay, and now let's check again the thing for that was why it was slower. So now what happened is that it needed more vRAM or more memory than we have in GPU memory. So now it uses part of it in CPU memory, and that's why it was much slower right now. However, it didn't break, and this is great. Because with vLLM, if you don't specify that the CPU should be used to a certain percentage, it just fails. At least in the examples that in the tests that I did. What did we learn now? We can run Ollama in a Docker container. We can use any model from the model list. They're all 4-bit quantized, and they're all GGF models. And we can run it in a Docker container. We can make curl requests against it. And the bigger the context window, the more RAM is needed. Now I want to unload the model because I want to have space for vLLM. We can do this like this, perfect. Now inside the Docker container of Ollama, no model is loaded. Now with vLLM, again, you can just use a command, which you can find in the description. What you have to do here is you actually need an account on Hugging Face and use a Hugging Face token. Try it out after the video. Maybe I didn't delete it. What you can see here is the Docker image. It's called vLLM OpenAI. I'm not sure why they call it OpenAI. I think it's because they say that the server, the vLLM server, is compatible with the OpenAI API format. That's why. And the model here, we will change it to something else. Let's try out this one here.
Copy that.
So here we specify immediately which model we want to run. And then what should be the context window size. So let's start with a smaller context window of, 2,000 tokens, just like with Ollama, that we can compare it a bit. 2,084. And but actually I want to run it in the background like this. Should be worked done. Great. And now it's again downloading everything. It will take a little bit longer to get it running because vLLM it takes longer to set up, but then at runtime it's in general a bit more performant or much more performant than Ollama. However, we have to wait. Okay, now let's see if it started correctly. Yeah, looks good. If there are no errors, that should work. Now we can run it with this call command. We have to change the model, right, to the one that we just started. Oh, it didn't start up yet properly. Okay, then we wait a little bit more. Okay, let's check out again the logs. No, it says application startup complete. Okay, now we should be good to go. I forgot. So I did something wrong here with option stream true because it's not streamed, but the request will come through. So there we are. Now we have the answer. Perfect. And now we can check out, we could do it already before, how much RAM we need. Oh, so we're almost full already with the context window of 5,000 tokens. So you can see this model, they're both 70B models. Like this one is 70B AWQ, optimized for 4-bit precision. This one is also a 70B model. This is a GGF model, optimized for being small and being able to load in quickly. So you could see how to work with vLLM, and you could also see that it's quite a bit more complicated than with Ollama. We saw what we had to do in order to choose the right LLM infrastructure. First of all, we talked about which models are actually right now really good. You can use the LLM Arena, you can use other resources. Then you can use vLLM or Ollama to run your models. Ollama has a very nice area to search for models. It's important how many billion parameters a model has. It's important that it either is here in this list for Ollama, so that it's optimized for Ollama with a 4-bit quantization, or if you use any model for vLLM, that you also make sure that here, for example, you can see here we have the GGUF optimization, which is for stuff like Ollama. Then here we have the AWQ optimization, which is better for which can be used for vLLM. And so you would go to the AWQ. There are also other optimizations, which we didn't touch on, but this is one of the more common ones. And then it shows you how to run it here, either in Docker or without Docker. Then we looked at how we can spin up an instance on paperspace. It was very straightforward. And as you could see, everything we did was basically just a few Docker commands and a few curl commands. So it's no rocket science, but you have to keep in mind like the different things with the parameter, with the context window, how these different parameters influence each other, and which hardware you need for certain models, or which models you can run on the hardware that you have, either your local laptop, a server in your business, or you rent something in the cloud like I just did. So yeah, now you know how to serve them right.
Free audio post-production by alphonic.com.